Welcome to 82nd lecture. We are studying transient analysis, and in this lecture, we will solve an example containing resistors and an inductor and a DC voltage source in the presence of a switch which remained closed for a very long time unless this circuit achieved steady state, and it was then opened at time t is equal to 0, and we have to find I1 of t. Right. So when the switch remained closed for a very long period of time, this inductor in steady state would be replaced with a short circuit, because we have studied that the initial current through an inductor is zero, because it cannot change. It doesn't allow sudden changes or quick changes of current through it. But once it is exposed to a voltage source that causes current flow through it, and once steady state is achieved, it is replaced with a short circuit. So at time t is equal to 0 minus, just before we have opened this switch, we achieved this. This inductor is short circuited and the remaining circuit is this. So this voltage 12 volt appears across this 6 ohm resistor and across this 12 ohm resistor. So causing a current 12 over 12, 1 ampere through this 12 ohm resistor. So I1 comes out to be 1 ampere at time t is equal to 0 minus. At time t is equal to 0 plus, it cannot change because current through inductor cannot change all of a sudden. Therefore, I1 at 0 plus is the same at I1 is equal to 0 minus 1 ampere, because this charged inductor starts acting like a current source, but not forever, only for a limited period of time that we'll see shortly, and causing a current flow through it equal to the current at which it was energized or charged. At time t is equal to infinity, I1 becomes 0, because this current source is a temporary current source causing a current flow through this circuit only for a limited period of time. And then we are ready to compute the expression for I1 of t, the only desired quantity in this example for all t, for all values of time. That is, we have to draw this circuit once again, and then we can use KVL equation to express voltage drop across each of the elements. So this 6 plus 12, I have added these two, they become 18 times I1 of t is the voltage drop across this 6 ohm and this 12 ohm resistors, plus the voltage drop across 2 Henry inductor is L di by dt, where L is 2. Putting this 2 instead of L, di1 by dt, I1 is the current flowing through this circuit. So dividing the whole equation by 18 gives us the time derivative of I1 of t plus 9 I1 of t. Right, the general solution we already know for this first order homogeneous differential equation is k1 plus k2 e to the minus t over tau. So we have three unknowns, k1, k2, k1, k2, and tau. So we have these three unknowns. So let's find out. We already know that we have been studying that these unknowns can be found by computing initial and by putting initial and final conditions in this expression. So we put initial condition t is equal to 0. We know that I1 at time t is equal to 0 is, let's see what it is. I1 at 0 is 1 ampere. So we'll put 1 here, 1, and this e to the minus 0, putting t is equal to 0 gives us a 1. So this becomes k1 plus k2 is equal to 1. So, and then we'll put t is equal to infinity, and we have studied in the initial conditions that what is I1 at infinity, it is 0. So we'll put a 0 here, and k2 e to the minus t, when we put t is equal to infinity, this term becomes 0. So k1 is 0. Putting k1 is equal to 0 here gives us k2 is equal to 1. And then we'll put k2 in this equation, I1 of t. I1 of t becomes 0 because k1 is 0. A2 is 1, e to the minus d over tau. So we have computed 2 of the 3 unknowns. The only unknown left is tau. How do we compute tau? We'll put the computed value I1 of t in equation number 4. We'll put that in equation A, our original equation. This is equation A. This is equation A. So right, and putting that, we have to compute time derivative and then multiply this by 9, because where is this 9? This 9 is here. 9 I1 of t, 9 times I1 of t, and then taking this negative on the other side of the equation, it becomes plus, and then we cancel this e to the minus t over tau with this e to the minus t over tau. So 1 over tau is 9, or tau is 1 over 9. So this is the last unknown that we computed for I1 of t. So I1 of t is now 1 e to the minus t over tau. Tau is 1 over 9. So denominator of the denominator is numerator. So 9 comes in the numerator. It becomes e to the minus 9t. It's a rapidly decreasing exponential. It's a rapidly decreasing exponential with time t. We can draw it, and we can use MS Excel, like I have taught in my lecture, in one of my previous lectures, that you can use MS Excel to draw this function. So you can practice that too. Okay, that's all for this lecture, and we will keep on studying transient analysis of first order circuits in our upcoming lectures. Thank you.